Swayam Prabha. Digital India. Educated India.
Healthcare Technology Innovation Center at IIT Madras brings together technologists, engineers, doctors and healthcare professionals, industry and government all together on one platform to develop healthcare technologies for the country. Let's get to know more about it.
Innovation will not happen purely in a silo manner. So, you need to do a very collaborative innovation, especially in healthcare technologies. So, who are the people? So, if you look at a healthcare ecosystem, right, you have a lot of stakeholders, right? You have the doctors, hospitals, you have the public health personnel, then you have the industry, right? Then you have the patients, then you have the regulatory agencies, the government policy makers. So, IIT Madras did something which has not been done before, which is literally form a innovation center which has a platform where all of these guys can be brought upon, right. So, this is today this center has about 40 collaborating institutions, various companies, various hospitals, various government agencies, various policy think tanks, and all of them are together. As a result of that, today so far the technologies that are developed from this center have touched over 1.5 crore people, right. And this is not only in India, this is abroad as well. And there are about 7 products that are commercially successful based on technology that have come out of HTIZ. Today are actually leading commercial products in the market.
Let's have a look at some breakthrough innovations of HTIC.
This is one of the very first projects that we did in HTIC. So it is called as Mobile Eye Surgical Unit. So this was done in collaboration with the hospital called as Shankara Nethralaya and HTIC. So in India, if you see, 80% of the blindness is caused due to a problem called as cataract. And this problem can be solved using a 15-minute surgical procedure. But the thing is, in India, most of the ophthalmologists are located only on the urban areas, and people on the rural areas doesn't have a lot of access to do these surgeries. So, and it's impossible to build eye operating hospitals in rural areas because it's just like distributed in a very wide space. And we came up with the idea where there are like 2 bus-based setup which can actually travel across the villages to do surgeries and treat the patients. So this basically contains 2 Ashok Leyland buses, where one will act as a preparatory vehicle, the other will act as a surgical suite. So these buses travel individually to remote locations, find a flat land, settle themselves there, and it is joined using a part called as vestibule to actually create an operating theatre environment. And first the people are asked to screen themselves, and then they are taken in for doing the surgeries. This was very effective and successful in doing surgeries for larger scales, and actually accessible areas were like really high in this project. And there are 2 such units operating in India right now. One for covering the states of Tamil Nadu, Andhra and Karnataka, mostly in South India, and one is there in Jamshedpur. So with this project, we have actually done more than 30,000 plus surgeries for the people to recover from the cataract. So if you see in India, it's like mostly in the remote population, mostly in the rural population. So say we have a scenario of like screening people in the villages. So what usually happens is the doctors go to a village and ask the people to come to the city. But in real time, there are a lot of hidden charges or hidden costs that comes to the people. Basically, already the people who have this kind of problem are like old, so they have to be taken in by their offsprings or like friends or relatives. So when we take them to the city, the travel charges, the charges that they spend for like staying in a hotel and everything adds up to the value more than the operating cost. So with this project, we have impacted largely to say that the people can be can perform this surgery in their own villages at a very minimal cost that this hospital actually asks for from the patient, and it reduces or removes all the price that comes along with it. So with this, we actually can capture a wide range of socio-economic background of people. Since we worked with a lot of ophthalmologists, the next set of problem also came in the same domain. So one such product is Trinetra. So it was in collaboration with the startup company called as Forest from Bangalore. So they are one of the provider of affordable eye fundus cameras in India. So eye fundus cameras are the ones which can look inside the retina of the eye. So there were a lot of images collected of the retina, and which were used for processing. That was basically which we developed. It is called as IPAC, so eye processing, analytics and computing. So there are a lot of common disorders like retinopathy, diabetic retinopathy, age-related macular degeneration and glaucoma. So in India, this is widely spread, and only an experienced doctor can actually detect or diagnose this disease. But with this product, even an optometrist can actually use this product to give a preliminary assessment of these disorders and can provide a report where the patient can use it to take it to a senior doctor for confirmation and treatment. So with this, we can actually do a large and a wide scale approach in identifying the disease for the people of India. So this is an example of a product where we have worked with the startup company and actually also got an FDA approval for this product, and this is sold in more than like 50 countries across the globe. So this is one of the unique products in our research center. So it is called as Trinetra Neo, which is also jointly developed by the company called Forest, as we discussed for the previous product. So this comes as a handheld setup, which is basically used to diagnose the eyes of the premature babies. So if a baby is born before 9 months, during 7 months or 8 months, the body functionalities and the organs are like not fully grown or fully developed. To diagnose those babies, it is very critical to have a very unique setup that can actually be used for babies. And one important factor in that is the blood vessels in the retina of the eye are not fully developed. And because of that, babies get a problem called as retinopathy of prematurity. And it is a very serious disorder where in the later stages of their life, they might get blindness. So in order to diagnose it or tap it when they are in the baby phase itself, we use this handheld setup to keep it at the tip of the eyeball to capture the image, and we do a similar eye processing, analytics and computing to diagnose or detect whether the problem is there with the baby or not. So this is a very important product to the babies, and right now we have done more than like 250,000 screenings, and there are like more than 300 units deployed across 25 countries. So with this, a large area or like large group of people are getting benefited out of this.
Hi, I'm Amalan and I work as the image processing engineer in the endoscopy team. So I'll be explaining about this EMRI 108 neonatal ambulance, which is made for neonatal care. So we worked with government of Tamil Nadu, and they wanted a special ambulance made which is exclusively used to transport neonates, and so this is very different from the ambulances that are usually used for transporting adults. So in the 108 service, when adults are transported, so there are usually accident cases, and recently there was COVID, and there are so many other infections the ambulances will carry inside them. So by transporting neonates in the same ambulances, we are exposing them to such environment to which they are very susceptible, and they will pick up these diseases. So government of Tamil Nadu approached us, and they wanted us to design an ambulance which will contain all the equipments and the features that can be used to address the emergencies that is required to treat a neonate. Okay, so from things like cuffs, needles, incubators and many other things which is required specially only for neonates, which is not used for adults, we had to design and give them a positioning of how to equip the ambulance inside. The ambulance also comes with a stretcher which can be operated single-handedly by a female nurse without much efforts from like mechanically putting any effort to move it. Currently, there are 65 such ambulances operating in the state of Tamil Nadu, and we have been giving support to them through this. Thank you. So the next product that I will be talking about is iQuant. iQuant is a in vitro point of diagnosis equipment where we get to do blood tests, single blood tests, and we get the results in place here itself. Now, first I will cover about our collaborator. So we did this with J Mitra. J Mitra is a pioneer of qualitative testing in India. They make testing kits for pregnancy testing kits, HIV testing kits, vitamin D testing kits, and various other diseases, where you get to know a yes or a no from the test kit. So where usually it's given by marks on the cartridge, and it's just a yes or no that you get from doing a qualitative test. They collaborated with us to now convert these tests to make it quantitative. So because obviously when we get the numbers for tests like while doing HIV or vitamin D or HbA1c, we need to know the exact count so that doctors can make a proper diagnosis and give the correct amount of medication. So while doing this, the real challenge was to get to calibrate the device for measuring all these diseases, each of them having a separate cartridge. So these are cartridges that were manufactured by them. So the chemistry of this was taken care by J Mitra, and the electronics and the hardware in which this had to be inserted, we manufactured them. So now the blood preparation is to be done like how it is done normally for a usual blood test, and then the blood sample is placed inside these cartridges, and these cartridges have to be inserted into the device, and then the tests are there in the software programmed here, and once the tests are run, the electronics will read the cartridge and give you the numbers that is displayed as a result. The software also has provision to enter various patient data and have a storage of all the tests that it does. Now, this device is now about 700 devices are given to various test centers across India. So now what this facilitates is you don't have to have this in a huge test center. So this is mainly targeted for remote locations where only one blood test need to be done, and the blood sample need not be sent to a faraway test center where it takes 1 or 2 days to get the test report back. So till now we have integrated vitamin D, HbA1c, dengue and thyroid tests. As and when J Mitra comes up with new cartridges, we can just upload the calibration for that particular disease and make it working for that particular disease. So the next product that I will be talking about is ArtSense. ArtSense is born out of the cardiovascular research carried out here in HTIC. So ArtSense is a device that will give you a comprehensive cardiovascular health analysis. So to do this, we use ultrasound, and it's an image-free ultrasound. So we use a single A mode ultrasound probe, and we use it on the carotid artery, and we measure using the reflections, we measure the stiffness of the carotid artery. Now this stiffness increases with age, but with lifestyle adjustments you can have less stiffness even when you are old, or you can have the vice versa, which can happen due to other lifestyle alterations that happen. Now the device can also be now used to do a more comprehensive cardiovascular health analysis, wherein it can be combined with brachial and femoral blood pressure cuffs, which will measure pulse wave velocity. And this pulse wave velocity with a combination of the carotid artery stiffness and the central blood pressure will now help us in estimating a score that corresponds to your vascular age, which is again telling you that you can be very old but have a very young cardiovascular health. This now helps you in also determining a bad cardiovascular health when you are young, and therefore can prevent you from going to before getting the cardiovascular symptoms where you have to be addressed in a medical environment. You can make lifestyle changes and then prevent these cardiovascular problems from affecting you.
So myself Shankar, I am a clinical application specialist for the cardiovascular team, and she is Aishwarya, who is also part of cardiovascular team. Now I'll be demonstrating how this ARTSense works. So right now I've attached the femoral cuff on her left thighs. Then this is the A mode ultrasound probe. Now I'll initiate the software screen. All I have to do is to apply this gel and keep it on her artery and wait for the results to find. Once you keep like this, the algorithm will track the near wall and the far wall of the artery when placed correctly, and we'll have to just stay there for some time until the result page is being displayed. And this is a very quick way to find the health of an artery in a very short period of time, and its main advantage is that it is an image free ultrasound probe and it is a market ready product.
Hi all, this is Aparna from Healthcare Technology Innovation Center, Indian Institute of Technology, Madras. So I am from the Image Guided Robotic Surgery team of HTIC. We are developing India's first spine surgery robo at an affordable price with an industry partner from Chennai. So I'll be taking you through the workflow of our application. We have two parts to this. One is an image guided surgery system, and one is a robo guided or a robo assisted surgery system. Spine surgeons perform open spine surgeries, and it takes them about 2 to 3 hours per surgery. So the amount of time they spend and the fatigue that is caused can cause some kind of a human error during the procedure. So our system helps the doctor by when they do a minimally invasive procedure, we are giving them a navigation system which forms the eyes of the operation theatre, and they have full access to the anatomy even though they do not open the spinal anatomy. So before the procedure, a CT volume of the patient is taken, on which the doctor plans the procedure and where the pedicle screws need to be inserted. During the procedure, a CT or a C-arm images of the patient are taken to know the current patient position, and then help the doctor translate the plan from the preoperative stage to the intraoperative stage to reference markers that are attached on the patient as well as the tools that they use for the procedure. So the doctor has the freedom to choose the anatomy that he wants to perform on, and the radiation exposure that the patient as well as the doctor undergo are far less in a minimally invasive and image guided surgery system. During the process, the doctor has the ability or the freedom to choose which vertebrae they're performing on. For example, we can take T1 and T2 for now. And then we provide multiple registration options like surface registration, intraoperative 3D and 2D 2D options. So for an example, if we go with the surface registration, we are able to load the CT of the patient, and once the CT is saved, the doctor is able to pick points from the CT, and then the registration happens in 3D space, based on which he is able to position his instruments and pedicle screws based on the plan. A robo manufacturer KUKA organizes the KUKA Innovation Award every year. And this year, HTIC's robotic team took part in the Robotics in Healthcare KUKA Innovation Award. And we were one of the top 5 finalists and the only ones from Asia to be a part of this event. We were chosen from one of the top 50 robotic labs all over the world. So what did we propose? A robotic antenatal ultrasound scanning system that can be placed in primary healthcare centers. In most of the Tier 2 or Tier 3 cities or villages in India, expectant mothers do not have easy access to scanning centers or sonologists. Imagine an 8-month pregnant mother traveling all the way to the city. The risks involved, the danger, and the amount of time and money they need to spend on getting the antenatal ultrasound scanning deters them from having their regular mandatory checkups. So our proposal was to bring in a robotic system which can be placed in the PHC and does not require a skilled sonologist right there. And how does a sonologist operate the robo? He can be in any city and we give him a VR headset. From the VR, using the joysticks, he is able to maneuver the robo, which will actually be performing his actions in real time at the healthcare center. So we provide two options here. One is a remote mode. Like I said, the sonologist in some part of the world is able to access the robo and the antenatal ultrasound scanning can happen. And in the other option, certain mandatory scans that need to take place every time the mother goes to the sonologist has been automated. The robo knows where is the abdomen, what are the positions or scans it needs to take in order to know the fetal heartbeat or the fetal position. So we are able to automate all of this, which reduces the sonologist's tasks by around 30%. So it's a win-win situation for both the mother as well as the sonologist, who most often complain of musculoskeletal issues due to the amount of pressure they need to apply in order for the scanning to take place. We also provide options for the sonologist to annotate the data or make measurements, and anything that he can do with his ultrasound system at the comfort of his clinic can be done by him, even with the PHC robo at the PHC. So the idea of providing a VR headset is for us to give the sonologist an immersive experience of the entire PHC room. He is able to see the robo model, he is able to see the anatomy of the patient all in 3D, and it gives him the feel that he is present right there in the PHC and doing the scan. And along with this, we also provide the 2D feed in the VR space such that he is able to see the patient as well as the movements in real time. Thus, this application we have envisioned in order to help the sonologists as well as mothers in PHCs and other rural areas who do not have access to scanning centers or skilled sonologists.
Hi, my name is Rahul Manoj. So I am a senior PhD scholar with IIT Madras, and I'm been part of the cardiovascular team at STIC, and we have been involved in developing cardiovascular medical technology devices as a preventive care for cardiovascular diseases, as well as to identify pathophysiology conditions in human subjects. And as you have already might have seen, the device called ArtSense, which has come out as a spin-off from the ongoing research in the cardiovascular field that we have been doing over the last 5-10 years. So a typical research, what we normally do, undergoes 4 stages of evaluations. So first, we develop algorithms and medical device prototypes, and this undergoes first level of testing, repeatability and measurements capability in silicon-based phantom setups. Then we move on to excised arteries, which we harvest from the butchered animals, and we have the pumping setup over here that mimics the heart, and which will be able to emulate realistic conditions on the excised arteries, wherein the prototype devices and algorithms are made into test conditions. Thereafter, we move into real animal studies where invasive surgical procedures can be performed for reference measurements, where our target measurements are mostly non-invasive in nature, and the animal is anesthetized and more controlled environment can be made, and a wide range of physiological measurements can be measured. Thereafter, finally, we move into human subjects, non-invasive human studies, which can be standalone camps or associated with certain hospitals. So these 4 levels of validation studies is more generally take place for all the medical device prototypes and algorithms that we normally develop. And ArtSense is one such device that is market ready and has gone through the entire life cycle, all the way from phantom experiments to human subjects currently. The ArtSense, although primarily focuses on measuring the arterial stiffness based on the carotid artery measurements, which you might have already seen the demo. So current research focuses in not just the arteries of the vasculature, but also into the veins and also the working of the heart.
I'm Amalan, and I'm from the endoscopy team, and I work as an image processing engineer in this team. So I'm showing you the endoscopy product. This is India's first indigenously developed endoscopy product, and we've developed this product for doing gastroscopy as well as colonoscopy. Now this endoscopy system consists of 2 parts, mainly the video processor and the endoscope that I am holding in my hand. So now this the scope that you see is a very complex product, and to make this, it's really a very complex procedures need to be followed. These systems are now majorly monopolized across the globe by three companies, namely Olympus, Pentax and Fujifilm, and they cost around 60 lakhs or even more. Now our target price to develop this in India is about 1/3 of that, and we have been able to do this with the help of BIRAC under the National Biopharma Mission, which supports and funds our product. So I'll just go into the components of the endoscope. So this endoscope has complex systems which includes electrical as well as mechanical components. There is electronics in the hardware present here, which helps us in interfacing a camera imaging sensor with our video processor, and we also have mechanical components in this handle which helps us navigate the endoscope inside the body. And this endoscope system, which with Mitra Industries, which we have developed, has a special feature in which we have LED at the tip, and we do not have a separate lighting system inside the processor here, which needs to be addressed for its thermal problems. So with LED at tip, we get better lighting at a lower energy, and we also get a clearer image on the screen. Similar to this scope, we have other scopes which can be used for other scopies like bronchoscopy, ureteroscopy, which can be interfaced to the same video processor. Now the video processor runs a software which completely converts the raw image that comes from our sensor to the image that you see on the screen, and there are a lot of features that we have developed along with this, wherein you can store all the patient information and give various settings for the doctors or the users who use this software. And we also have video recording and video image recording feature inbuilt in this, which is not currently available in many contemporary systems.
Hi, I'm Anthony Raj, Chief Project Engineer at HTIC. So this research work is one of the extended research of the endoscopy team, where we have worked on advanced stereoscopic images. So usually in an endoscope system, there will be one image sensor. So here we are trying to implement two image sensors and perceive a 3D image output from the endoscopic applications. So these are like minute cameras which are in like 3 cross 3 mm in dimension, which will be implemented at the distal tip of the endoscopy system, which has various applications like viewing of the growth of the polyps of any cancerous region, and it has like a variety of application during surgical procedures. So during the procedure of a 3D endoscopy system, so the doctor will basically able to visually diagnose using any 3D monitor or using a VR headset. Based on various maneuvering and user aspects, we can actually find the depth of any object that we see in the image. As a part of the endoscopy project, here we are trying to tap some of the core research in this area. Primarily, we are focusing on the areas of light tissue interaction as a moving path for finding early cancer detection in the human body. Generally, in endoscopy system, we use RGB cameras, but here we are using multispectral cameras. So these cameras are the sensors that can actually capture the images at many different wavelengths. So with this research in hand, we have carried out a preliminary research work on the oral cancer region, where we are trying to identify early squamous cell carcinoma and the normal tissue. So basically it contains different spectral frames where we apply a lot of oxygen saturation and other algorithms that will facilitate us to identify cancer at an early stage. When this project is done, it will be one of the impact features in an endoscopy system that can actually save a lot of life in terms of saving people from dying of cancer and identifying it at its early stage itself. Thank you.
Innovators and entrepreneurs, the first thing we tell them is you have to spend enough time in identifying and understanding the problem really well. You should become the top 1% of the experts in understanding the problem. You may not have the solution, but a poor understanding of the problem will actually lead you to all kinds of wrong solutions, or sometimes solutions which you realize you don't need and which are not commercially viable. So, understanding of the problem, which means can happen only through immersion. You have to go immerse yourself, embed yourself. There are ways you first start learning, but you actually have to be what they say on the ground.